With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The given question is, in the figure, what should be the speed of the charged particle so that it cannot collide with the upper wall? Also, find the coordinates of the point where the particle will strike the lower plate in the limiting case of velocity. Okay, so we are given a particle that is entering a magnetic field which is inside the screen with a velocity v and of mass m and charge q. Okay, so now we have to find the speed of the charged particle such that it is not colliding with the upper wall. Now we can see that from the figure that the particle is entering at a velocity v which is perpendicular to magnetic field. Okay, so whenever this is the case, when velocity is perpendicular to magnetic field, the particle performs a circular motion. Okay, the particle performs a circular motion. Okay, so this particle will move in a circular motion and it will come out of the lower plate. Okay, after completing the semicircular motion. Okay, now we have to find the speed such that it cannot collide with the upper wall. Okay, so we have to find like the path, or we can say the velocity, where this particle is not touching the upper wall or colliding with the upper wall, such that it is just moving just before it is about to collide the upper wall. So that is, we can say that if r is the radius of this semicircle, then the value of this r must be less than the width. Okay, the width, that is d, and we know that the formula for r is given as mv over qb. So this must be less than t. So from here we can say that the velocity must be lesser than q b d over m. So this is the answer for the part A. Okay, so this must be the velocity such that the particle will not hit the upper wall. Now we have to find the coordinates of the point where the particle is striking the lower plate. So at this point the particle will be colliding with the lower plate in case of limiting case of velocity. Okay, so if I take the limiting case of velocity, then velocity will be equals to q b d over m. Okay, and in this case this will be the radius r and this would be the radius r again. And if in the limiting case of velocity, the radius r will be equals to the width d. Okay, so we have to find the point where the particle is striking. So at this point is at a distance of 2r. So I can write here this point will be at a distance of 2d also. Hence the coordinates of this point, let's say this point is p. So coordinates of the point p will be given as minus 2d if I am taking this to be the origin. So the coordinates would be minus 2d 0, 0. So this is the required answer for part B. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.